Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to the Natural Sciences lesson. My name is Towigle Tebe, and this program is proudly brought to you by the Houghton Department of Education. And our topic today is visible light. This is the last of this topic. It's the last lesson. And our subtopic is reflection of light, seeing light, and refraction of light. Let's check our objectives. Remember, we have to set a goal for ourselves. We want to achieve something at the end of this lesson. What are we going to achieve, grade 8? First of all, we are going to explain that light is reflected off most surfaces and changes directions when refracted. Remember, when we are talking about refraction, we are talking about bending of light. All right. And then we are going to state and use the law of reflection. And we're also going to explain reflection caused by smooth and rough surfaces. We are also going to state how light is refracted by transparent substances. And we're also going to describe the action of prism and lens on light. And finally, we're going to describe how the eye receives light energy and how this is converted to an electrical impulse which travels to the brain where they are interpreted. And we get all this from the CAPS document, page 51. Let's check the pre-knowledge. What did we learn in the previous grades? What do we know? Remember, in grade 7, you laid a foundation on this topic and you did the transfer of energy and you're focusing on the solar system. Okay. And we know that the ultimate source of energy is the what? It is the sun. Why? Because plants need the sun for photosynthesis. Remember what happens in photosynthesis. We need radiation energy from the sun. We need carbon dioxide from the atmosphere. We also need water from the soil so that plants produce their own food. Remember, plants are producers. This is the foundation that you have already laid, but today we're just building on to what we already know. And then we're going to do a baseline activity. Remember, in the past 4 weeks, we're doing visible light. Today, we are just rounding off everything. Name the 7 colors of the visible spectrum. Question number 2, which color of light has the shortest wavelength? These are the 2 questions that I want you to answer. I'll just give you 2 minutes to work on those. I hope you are done answering the questions, grade 8. If you are done, you can just shoot your work and send us on 064 748 8913. The number again, 064 748 8913. We would love to see your work. Please make sure you text only, you don't call this number. All right. We've got a team here which is going to answer all your questions if there's something that you don't understand. Let's look at our questions. Name the 7 colors of the visible spectrum. Then question number 2, which color of light has the shortest wavelength? And then our solutions. Question number 1 wanted you to list the colors of the visible spectrum. And the colors of the visible spectrum, in order for you to memorize them, please know Roy G. Biv. All right, if you say Roy G. Biv, you'll never forget the colors because it is R, which is red, O stands for what? Orange, Y, yellow, B, blue, I, indigo, then V, violet. Okay, these are the 7 colors of the spectrum. This is red, orange, yellow, green, blue, indigo, violet, which is Roy G. Biv. And then, which color has the shortest wavelength? It is violet. All right. Why are we saying it has the shortest wavelength? Let's look at the waves. All right. If we're given a wave like this one, this is the crest at the top and another crest. All right. This distance in between 2 consecutive crests is called the what? The wavelength. And then if we look at the trough, at the bottom we call it a what? A trough. Then if you look at this distance in between 2 consecutive troughs, we call that a wavelength. All right. Then red has got the longest. And then violet has got the shortest. If you check the distance between this trough and this trough, and this crest and this crest, check the distance. It is the shortest among all these 7 colors. All right. So our answer is violet. And then we are going to define terms. It is very important for you to know the definition of certain terms because it's going to be easy for you to understand the lesson. And even in your exams, you are going to be required to define terms. This is a base. You're going to define the terms from now up to grade 12. Okay, so make sure you understand these terms. All right, we're starting with incident ray. When we're talking about the incident ray, this is a light ray that strikes the surface of an object, and we call it the incident ray. And then it is an incoming ray because it is the one that strikes a surface. It's an incoming ray. And then we've got a normal. A normal is a line that has been drawn at right angles to the surface of an object. Okay. And then we also have a what? A reflected ray. When we're talking about a reflected ray, if an incident ray comes in to a shiny object and then light is reflected to our eyes, that is called a reflected ray. Okay. We're going to come across a diagram about this. You're going to understand better. All right. Let's go on. And we also have perpendicular. All right. When we are talking about a perpendicular line, this is a line. This is a line that causes a what? A right angle to another line or a surface. For example, let me do this. If I draw this, okay, this is the surface and this is the normal. It is perpendicular to the surface. It is 90 degrees. And then the incoming ray will be this one. It's incoming. Then the reflected ray will be this one. It will be outgoing. Okay. And then we've got retina. What do you think retina is? We're now talking about the part of an eye. A retina is a layer of light-sensitive cells at the back of our eye. Okay, it's very sensitive. This is when light gets in, it goes there and then it forms an image and then it is transported through the optic nerve to the brain. Okay, where the brain will interpret it as the color that we are seeing. Okay, and then impulse. It's a message that travels along a what? Along a nerve. That is an impulse. And then converge. When we are talking about converge, this is coming together. Converging is coming together to a point. All right. Remember when we started talking about visible light, we were defining diverge, where light diverges. But today we're talking about converge, which is the opposite of diverge. Do you understand that, grade 8? That's good. Let's carry on with our lesson. And then we've got refraction. When we are talking about refraction, we are talking about the bending of light. How does light bend? Remember, light travels in straight lines. Okay? And then when we are talking about refraction, when light, for example, white light strikes a glass prism, what will happen? It's going to bend. All right? And then when it bends, it will disperse. When it disperses, then we see the colors of the spectrum. And in nature, that is a rainbow. And how does it happen in nature? If it rains, or if we still have showers, or let me just say a droplet of water, and then white light shines on that droplet of water, what's going to happen? White light is going to bend, and then it will disperse. Then it will show a rainbow. All right. All those colors of the rainbow are the colors of the spectrum, and there are 7, and we have said Roy G. Biv. All right. That is red, orange, yellow, green, blue, indigo, and violet. Are we together? Good. And then we've got what? Refraction is what we're talking about. It is the ability of a wave to change direction or bend when it passes from one medium, such as air, and another, such as glass. And then let's look at reflection of light. Light is reflected off most surfaces, which is why we can see objects around us. We can see a lot of objects around us. It is because of reflection. Okay. And then when you look at a smooth surface, it is possible to see your image on that surface. For example, if you look at yourself at a window pane, you can see yourself. If you look at yourself using a mirror, you can see your image. Even using your phone, you can see your image. Okay, because it has got a what? A smooth surface. Okay, we've got an example of a mirror there. You can see this mirror here, grade 8. And then it is reflecting flowers. So far, it is reflecting a lot of things that are in the room. Okay. And then when light strikes a shiny surface at exactly 90 degrees angle, the light rays will be reflected straight back. Okay. However, when the light rays strike the object at an angle, the light rays are reflected at an angle. Okay. And then reflection involves 2 rays. We are now talking about the incident ray that we have said it is an incoming ray. Okay. And then when it strikes a surface, what happens? Light is also reflected. We call that a reflected ray. Okay. This is the ray that enters our eyes, and then we see the color. Okay. Because it is reflected. What about the other colors of the spectrum? They will be absorbed in that surface or in that object. Okay. For example, if we see a blue color, what would have happened? White light will strike that object, and then blue is going to be reflected to our eyes. And then the message will travel from the retina through the optic nerve to the brain. And then it is going to be interpreted as blue. You get that? Because blue has been reflected. And what happens to the other colors of the spectrum? The other colors of the spectrum will be absorbed. Do you get that? That's good. All right. Reflection involves 2 rays. We said incident ray, that is the incoming ray, and the reflected ray, which is the outgoing ray. We've got a good diagram here. This diagram is very clear. This is the incident ray, this one. It is an incoming light, and then it strikes a shiny surface. It's even written mirror here. This is a shiny surface, and then what happens? Remember, this is the normal, this is the imaginary line, which forms what? 90 degrees. It is perpendicular to the surface. And then when the incident ray strikes a shiny surface, what happens? Then the light is going to be reflected. Okay. And then that's when we can see the color of that surface. Why? It is because we only see what has been reflected to our eyes. Let's take, for example, black. If you see black things, what would have happened? White light will strike that object, and all the colors of the spectrum will be absorbed. Therefore, there is no color that is going to be reflected to our eyes. Therefore, we won't see any color, and the mind will interpret it as black. Even when you close your eyes. If you close your eyes, what do you see, grade 8? You can't see anything, it's dark. Why? Because there is no light that has been reflected to our eyes. Therefore, we see black. Okay. And then someone can ask, what about white? Because at times you can see white things, you can see white color. The white light will strike that object, and then all the light will be reflected back to our eyes. And then we'll see white. Because all the colors of the visible spectrum will be reflected back to our eyes. Okay. Therefore, it means we only see color when it is reflected to our eyes. Okay. And then the colors that we don't see will be absorbed in that object. Okay. That's good. The incident ray is the ray that falls on the reflective surface. This is the incident ray here. And then it falls on the reflective surface. This is the mirror. And then the outgoing ray is the what? Is the reflected ray. This is the ray that comes to our eyes so that we can see the color. Okay. The reflected ray is the ray that is reflected from the reflective surface. Okay. Let's carry on. And then incident ray, this is the light ray that travels to the reflective surface. You can think of it as an incoming ray because this is the white light coming in. This is the incoming ray, and then it reflects on a shiny surface, and then the outgoing ray is the what? Reflected ray. Okay, and then it will enter our eyes, and then it will go to the retina where the image is formed. Then the message will be transported through the optic nerve to the brain, and then the brain will interpret it as the color that we are seeing. Okay, and then the normal. What do you think the normal is, grade 8? If we're talking about the normal, we're talking about this line. It is an imaginary line. Okay, and then it forms how many degrees? 90 degrees to the surface. It's like this. It is 90 degrees. Okay. Normal, this is the line. It's an imaginary line on a reflective surface that forms at an angle of 90 degrees to the surface. And then the reflective ray, this is the light ray that is reflected by the surface, and you can think of it as the outgoing ray. Okay. And then let's continue, grade 8. This is interesting, isn't it? And then we are looking at the angle of incidence. This is the angle that is measured from the normal to the incident ray. If we are saying it is measured from the normal to the incident ray, what are we talking about? This is our normal, grade 8. This line is the normal. It is an imaginary line. And then we are looking at the angle of incidence. This is the incident ray. And then we are looking at this angle from the incident to the normal. Okay, incident ray to the normal. This is the angle of incidence. And then the angle of reflection. The angle of reflection is measured from the normal to the reflected ray. Let's look at the normal again. This is our normal and this is our reflected ray. And then the angle of reflection. We are going to measure from this line, that is the normal, going to the reflected ray. This is the angle of reflection. Okay, let's continue. And then the law of reflection states that for reflection to occur, the angle of incident ray should be equal to the angle of what? Of the reflected ray. Okay, this angle here, this is the angle that we're talking about. This angle should be equal to this angle. The angle of the incident ray should be equal to the angle of the reflected ray. Okay. And then we're continuing with the reflection of light from smooth and rough surfaces. Okay. Remember what we said about a smooth surface. We said you can see your image on a smooth surface. Okay. A mirror has a very smooth surface. On a smooth surface, all the light is reflected in the same direction. Therefore, there is a pattern that is taking place here. Therefore, you can see an image. You can see yourself there. Okay. And then let's look at these eyes. This eye sees light. Why is it seeing light? This eye here. It is seeing light. Why? Because there is a reflected ray. This is the reflected ray. Reflected ray. Remember what we said about the reflected ray. We said the reflected ray is the outgoing ray. This is the reflected ray. Okay, it is the outgoing ray. This is what comes to our eyes. And then it will be interpreted by the brain as to what we are seeing. And then when you look at this eye does not see the light. This is the eye we are talking about. It doesn't see the light. Why doesn't it see the light? Because there is no light that is being reflected to it. Okay, this is the incident ray. Incident ray. It is the incoming ray. Okay, when it comes and then it strikes a smooth surface, what will happen? Then it will reflect. Okay, then this eye is receiving light from the surface. That's why it is seeing light. Do you understand that? That's good. Let's carry on. And then we are going to continue with the reflection of light from smooth and rough surfaces. On a rough surface, now we are concentrating on a rough surface. Different light rays will shine on different parts of the surface. So some might shine on relatively flat parts, and some might shine on parts that are at a greater angle away from the flat surface. Okay, you can see this is a rough surface. It is not smooth, it is rough. All right, then light can shine on a flat surface, and light can shine on a surface that is not even. All right, and that surface that is not even, remember, it is opaque. And it brings us back to the word opaque. What does the word opaque mean? When we are talking about opaque grade 8, we are talking about an object or a surface that is opaque, where light cannot travel through. For example, my hand is opaque. When light shines here, it does not travel through. Why? Because it is opaque. It blocks the light. Therefore, on the other side, there will be shadows. Okay, this happens to the what? To a rough surface. And then light will be scattered. Okay, there won't be an even pattern, but it will be scattered. Okay, this is what is happening on a rough surface. And then I, at both positions, see the reflected light. Why? Because light is just scattered. There is no pattern. Do you get that? Let's move on. The shadow takes its shape from the shape of the opaque object and will form on the side. facing away from the light source. For example, what we said about the hand. The hand is opaque, therefore it blocks the light. The light doesn't travel through. And then what is going to happen on the other side, there is going to be a shadow. All right. Let's continue. Great. 8. When light is reflected from rough surfaces, not all the light that is reflected reaches the eye. Why doesn't it reach the eye? It is because it is scattered. All right. It is scattered. And therefore, the brain is not able to form an image. Okay. Remember, in order for us to see color, what happens to our eyes? White light strikes an object, and then light is also reflected into our eyes. When it enters our eyes, it is transported to the retina, and then from the retina, it goes through the what? The optic nerve to the brain. And then the brain will interpret it as the color that we are seeing. For example, if white light strikes a green leaf, what's going to happen? Green is going to be reflected to our eyes. That's why we see a green leaf. And then what happens to the other colors of the spectrum? Remember, it's not green only. All right. You remember RGB. All those are the colors of the spectrum. And then the other colors are going to be absorbed. That's why we don't see them. That's why they don't reflect to our eyes. Okay. We only see the color because it has been reflected to our eyes. Okay. All right. The light is scattered, which means that it reflects in several different directions with no regular pattern in the reflection. That is a what? A rough surface. It's just the opposite of what? Of a smooth surface. Because with a smooth surface, the eye will see light. For example, this one. This is reflected here. It is reflected. And then this one is an incident ray. It is incoming ray. Incoming ray. Okay. Then it will strike a what? A smooth surface. And then there is going to be a reflected light which will come to our eyes. And then our brains are going to interpret it as what we see. The smoother the surface, the more the light is reflected in the same direction, and therefore the clearer the image that forms. The image will be very clear. For example, if you take a mirror and check yourself, you will see a clear image of yourself. Okay. Why? Because it is a smooth surface. If light strikes that surface, then there will be reflected rays which will come to your eyes, and then it will be interpreted as what you see. Let's continue. We've got an activity grade 8. Let me read the questions for you. Question number 1 says, what is the normal? Question number 2, what are the incident ray and reflected ray? And then question number 3, draw a diagram of reflection of light showing the incident ray, the reflected ray, including the normal. Okay. So I'll give you 5 minutes to answer this activity. You can start answering the activity now. Hope you are done writing the activity grade 8. If you are done, please just send us your answers. We would love to see your answers. And our number for the WhatsApp is 064 748 8913. Our number again is 064 748 8913. Let's check our answers. Okay. Question number 1. Normal is a line drawn at right angles to the surface of the what? Of an object. And then incident ray. This is an incoming ray. This is a light ray that is incoming, and then it will be reflected to a surface, and then the reflected ray is going to go out. All right. Incident ray is the light ray that strikes the surface of an object, and then the reflected ray is the ray that is reflected from the reflective surface. And then for number 3, the question wants you to draw a diagram to show the normal, the incident ray, and the reflected ray. This is the way you are supposed to do it. This is the incident ray. It's an incoming ray. Okay. This is white light coming in to a smooth surface. Okay. And then it will be reflected, and we call that a reflected ray. And then here we've got the normal. This is the imaginary line. Okay. And it is perpendicular to the surface. Why are we saying it is perpendicular to the surface? It is because it forms how many degrees? It forms 90 degrees. And then we've got the reflected ray. This is the outgoing ray. This is the important ray because when it reaches our eyes, we see the color of the surface. Okay. This is the color that we see because light will enter our eyes. Okay. Therefore, if you did your answers like this, this is correct, correct. Excellent work if you got it correct. Okay. Even if you didn't get it correct, you'll get it correct next time because now you know. Okay. You'll write your corrections so that you won't forget. Let's continue. Great. 8. And then seeing light. Light of different frequencies passes through the cornea because it is transparent and enters the eye through the pupil and travels to the retina. And what happens when it reaches the retina? It will be transported, forms an image, and it is transported through the optic nerve to the brain. And then the brain is going to interpret it as the color that we are seeing. If the color is yellow, let's talk for example yellow surface, what's going to happen? If white light strikes a yellow surface, and then yellow is going to be reflected to our eyes, and then we are going to see yellow. What happens to the other colors of the spectrum, grade 8? What happens? The other colors of the spectrum will be absorbed. Okay, only yellow will be reflected. That's why you will see what? That's why you will see yellow. Okay. Specialized receptor cells in the eye's retina are stimulated by specific frequencies or colors. When we are talking about frequencies, do you understand what you are talking about, grade 8? All right. When we are talking about frequencies, we are talking about the number of waves that pass at a certain point at a given time. All right. And then, for example, we've got red. It has got the longest wavelength. And what about the frequency? It has the lowest frequency because the waves are long. Okay? Therefore, maybe one wave is going to pass at a certain point at a given time. But if we compare to violet, violet has the shortest wavelength. All right? Excuse me. And then when we compare to violet, violet has got the shortest wavelength. And then there will be a lot of waves that will pass through a certain point at a given time. Okay. All right. Let's continue. Grade 8. The light energy that forms an image on the retina is converted to electrical nerve impulses. These impulses travel through the optic nerve to the brain, which interpret the impulses and tells us what we are seeing. If we are seeing green, what would have happened? It means when white light strikes an object, then green will be reflected to our eyes, and then we are going to see green. Okay, that's how it works. And what about the other colors of the spectrum? They will be absorbed. Okay, that's why we don't see them. That's why they are not reflected. Is that clear, grade 8? That's good. Why objects appear to have a certain color? Think about a sunflower, a yellow sunflower. What happens to a yellow sunflower, grade 8? When white light strikes a yellow sunflower, what would happen? Only yellow will be reflected to our eyes. Remember, we see the color because it has been reflected to our eyes. It enters our eyes. That's why we see color. But if it's not reflected, like black, we won't see anything. If you see dark, which is black, because the colors of the spectrum will be absorbed. Here we are seeing yellow. We are saying why? It is because the yellow color is reflected. Okay. And what happens to the other colors of the spectrum? The other colors of the spectrum will be absorbed. Okay. Let's continue. White light from the sun shines on the petals of a sunflower. The petals absorb all the colors of the spectrum except for yellow, which can reflect. Okay, since only yellow light will reflect to the eye and all the other colors are absorbed, only yellow light will reach the eye's retina. And then it will be transported through the optic nerve to the brain. And then the brain will interpret it as yellow. That's why we see yellow sunflower. Okay. And what about the other colors of the spectrum? They will be absorbed. Okay. All right. For example, we've got a good example here. This is white light. It is an incoming ray. Okay. It is the incident ray coming into a yellow surface, and then the reflected ray is what? It is yellow, which is reaching the eye. And then it will be processed and interpreted as what? As yellow. Okay. Because yellow is the only color that is being reflected to our eyes. And what about the other colors of the spectrum? They will be absorbed. Okay. Interesting, isn't it? Therefore, the brain will interpret the color yellow from this information. Okay? And then let's look at refraction of light. When we are talking about refraction, remember we are talking about the bending of light. Remember, light travels in straight lines. Okay? And then once it hits a medium, for example, maybe a glass, then it will bend. Okay? We call it refraction. And then when it bends, what happens? It will disperse. Then we will see the colors, Roy G. Beef. That is red, orange, yellow, green, blue, indigo, and violet. And then what about in nature? In nature, if it's raining, let's say maybe it's after raining, and then we still have some showers, and we have the sun. What will happen? White light is going to strike a what? A raindrop, and then it will refract. That means it will bend, and then after bending, then it will disperse, showing the rainbow. Then we'll have a rainbow. Okay, that is the color of spectrum. Okay, and then you have already learned that white light travels from one transparent material to another. It refracts, that is, it bends. We've got a good example here. We've got a picture of a glass prism. White light is striking the glass prism, and then what's happening? It is refracting. It is bending. Okay, it refracts. When it bends, then it disperses. Then we are seeing the colors of the rainbow. That's why I was seeing all these colors of the rainbow. This is red, orange, yellow, green, blue, indigo, and violet. Okay. And then different wavelengths of light will refract by different amounts. This explains why the glass prism disperses white light into the colors of the rainbow. Okay. Let's go on. Different colors of light will refract with different angles. They will refract differently. Okay. Then refraction of light through a triangular prism. Light enters the glass at an angle to the normal and refracted towards the normal. Okay. On the second surface of the glass, the light is refracted again. Okay. But the normal of the second side is not parallel to the normal of the first surface. Okay. We've got light here. White light is entering. It is striking a glass prism. This is a glass prism. And then what's happening here? You can see it's bending. This is refraction. Okay. And then it disperses. When it disperses, it shows us the colors of the spectrum. Okay. And then this is why light changes direction completely. Light travels from glass to air and is therefore refracted away from the normal. Okay. And then refraction through a what? A lens. When light travels from air to glass, it reflects towards the normal. In the case of a curved surface, the normal will be perpendicular to the tangent on the surface. Okay. For example, we've got a diagram here. Do you see this diagram? This is light coming in and then it refracts. Okay, it bends. The parallel light rays enter and leave the lens. They refract to eventually focus at a specific point. It changes direction. This is how it changes direction. Look at this light. It's straight from here and then it's also straight, but it is refracting and then it changes direction completely. Okay. And then refraction through a what? A lens. The rays are focused on a specific point because the lens is convex. In other words, it curves outwards. It will be curving outward. All right, this is a good example of what? Of a convex lens. And then light is coming in here, okay? And then it refracts, okay? Do you see it bends? This is refraction. Okay, it changes direction. Okay. Amongst other things, lenses are used in practice to focus or bend light, to enlarge images, or to correct eyesight. For example, there are some people who are putting on spectacles. Why? Because their eyesight is being corrected. At times, it is because we want to enlarge things. Okay. Lenses are also used in the following instruments. We use lenses in these instruments. Okay, all these we are using lenses. And then let's go to our summary. Light reflects off most surfaces. Okay. And then light changes its direction when it is reflected. It changes direction. And then the laws of reflection tell us how light is reflected. On smooth surfaces, light is reflected in the same direction. Okay. And then what about on rough surfaces? Light is scattered. There is no pattern. Okay. For example, on this picture here, it shows a rough surface. You can see light is traveling in straight lines. This is the incident ray. That is incoming light. And then when it strikes a surface, if it's a rough surface like this one, then light will be scattered. Okay. Eye at both positions sees the reflected light, but it's difficult for the brain to interpret it. And then objects around us reflect or radiate light with different frequencies that enter the I. When we are talking about frequencies, remember we are talking about the number of waves that pass at a certain point at a given time. We call that frequencies. Okay. For example, if we look or if we compare red and violet, red has got the longest wavelength and the lowest frequency. And then violet has got the shortest wavelength and the highest frequency. Why is that so? It is because when we are measuring frequency, we are talking about the number of waves that pass at a certain point at a given time. All right. And then specialized receptor cells in the eye's retina react to specific frequencies or colors. We've got an example here. Let's look at red. We said red has got the longest wavelength and the shortest. It has got the what? Longest wavelength and the lowest frequency. How is that so? Let's look at the wavelength. Let's look at this crest and this crest. Okay, the distance in between these two crests is very long. All right? And then the distance in between these two crests, it is very short. Okay. This is red, remember, and this is violet. Red has got the longest wavelength and violet has got the shortest wavelength. But when it comes to frequency, we are measuring the number of waves that pass at a certain point at a given time. For example, if we check how many waves will pass from this point to this point. Okay. Then here we'll have how many? We'll just have one wave. It shows that the frequency is low. And then if we put the same distance from here up to here, how many waves will have passed that point? We'll count the number of waves. 1, 2, 3, 4. You see, here it is 1, here it is 4. It shows that the wavelengths are different. Okay. Therefore, the frequency is going to be different as well. For red, the wavelength is long. It is the longest, but the frequency is the lowest because only one wave will pass at a certain point at a given time. But with violet, a lot of waves are going to pass at a certain point at a given time. Okay. Let's continue. Grade 8 with our summary again. In the eye, light energy is converted to electrical nerve impulses. And then these impulses travel to the brain and the brain interprets them as what we see. Okay. If we are seeing green, the mind would have interpreted as green. Why? Because green will be reflected to our eyes. And then our eyes are going to see green only. Why? Because the other colors of the spectrum will be absorbed in the surface where green is being reflected to our eyes. Because we only see color when it reaches our eyes. If it doesn't reach our eyes, we don't see that color. Okay. Let's continue. Light can be refracted by transparent substances. When we are talking about refraction grade 8, we are talking about bending of light. Okay. Remember, light changes direction and it can refract. That is, it bends. Okay. When light strikes a glass prism, what happens? Light will refract. It will change direction and then it will disperse so that we see the colors of the spectrum. Okay. And then when light travels from air to another transparent medium, the light changes direction towards the normal in that medium. Okay. And then when light leaves the transparent medium, it changes direction away from the normal. And then a triangular prism can reflect and disperse white light into the colors that are seen in the rainbow. A lens can reflect and focus light. Okay, for example, this is white light. White light is striking a what? A glass prism. This is a glass prism. And then what's going to happen? Light is going to refract, is going to bend, is going to change direction. Okay, it will bend and then it disperses. That's why we see the colors of the spectrum. For example, here we are seeing red, we are also seeing orange, we're seeing yellow, we're seeing green, blue, indigo, and violet. Why? Because the white light struck a glass prism and then it refracted, that is bending, and it dispersed, showing the colors of the spectrum. Okay, let's continue. We are going to our WhatsApp. We want to check your questions grade 8. Remember, our WhatsApp number is 064 748 8913. If there is something that you didn't understand, please make sure you ask. Okay, let's check your questions now. Do we have questions here? All right, it seems we don't have questions. Therefore, we'll go back to our lesson and then we are going to revise what we have already done. For example, we'll go back to our summary and then we're going to talk about things that you didn't understand so that you understand. Okay. All right. Before we do that, we've got a homework which I want you to copy into your books. All right. Let me read it for you. Question number 1 says, complete the following diagram to show how light will pass through a glass. And then number 2, draw a wavelength of red and violet. Okay. I'll just give you 2 minutes to copy the questions into your books. And then you're going to do this at home and bring it to class next time you come to school. Okay. Hope you are done grade 8 copying the homework. Make sure you do the homework at home and bring it to class. Okay. And then now we are going back to our summary so that we talk about our topic. Remember, this is the last lesson on visible light. Okay. Okay, we'll summarize our lesson again so that you understand. All right, light reflects off most surfaces. What are we talking about when we say light reflects off most surfaces? When light strikes an object and then light is also reflected to our eyes. That's why we are seeing different colors. Okay. And then if we see a certain color, it means the other colors are being absorbed in the what? In that surface. For example, if white light strikes a green leaf, then we're also going to see a green leaf. Why? Because the green will be reflected to our eye. And then we only see the light, the color of the light that we are seeing. Okay. And then the laws of reflection tell us how light is reflected. For example, on smooth surfaces, light is reflected in the same direction. You get that? And then on rough surfaces, light is scattered. Okay, there is no pattern. And then in the eye, light energy is converted to electric nerve impulses. Okay. And then impulses travel to the brain and the brain interprets them as what we see. And then light can be refracted, which means it bends. Okay. For example, this is a good picture showing that light is refracted. Okay. It bends and then it disperses, showing us the colors of the rainbow. Okay. And then now you are going to, this is a reminder that you are going to press the complete button at the end of this lesson to show us that you have completed the lesson. Okay. Thank you very much. Grade 8. Make sure you sanitize, you maintain social distance, you always wear a mask. Be kind to yourself. So long for now.